Well, a lot of the efforts out there are to clean up that oil. The effort's still going on right now, still to drill those relief wells to ultimately stop the leak. But some people have ideas on how to stop it themselves. Would you believe someone thinks magnets are the way to go? You heard me right, magnets to possibly stop this oil leak. And my next guest can explain this to you, because I certainly have a lot of questions about that. His name is Mark Senti. He's founder of Advanced Magnet Lab. Sir, thank you for being here. And I guess let's just start at the top. How is this supposed to work?
Thank you, TJ. Well, what we've done is demonstrated how we can apply magnetic spheres and steel balls down into the well, into the Gulf, to slow this leak or this spill to a leak, or entirely stop it if we want to. It's a very safe, a very benign, very low-tech solution, and we've now demonstrated that in a scaled version in our laboratory.
Well, you talk about that laboratory, and let's show it to our viewers. We'll put it up and have you talk about it here, but we can show you this demonstration you had. Now, how big and how many of these magnets are we talking about? You would essentially have to get down to the floor of the ocean.
Well, just to give you an idea, in our lab here, we are emulating what would be equivalent to it as a 44,000 barrels per day flow. We're doing it in a 3-inch pipe, which compares to approximately 20-inch in a well, so a very, very good demonstration. And we are applying only in a very small area in this pipe, approximately 26 inches, a mixture of these magnetic spheres and steel balls. And only over 26 inches, we were able to show that we can reduce this to 75%. If we would have added additional pipe and additional materials, we would have brought this to a stop. And we measured along the length of this as we applied the materials, and we showed the phenomenon that it is very linear. So it shows you that it will work to bring it to a controllable stop.
Now, do you have a monitor there in front of you by chance? Did you see that demonstration
Yes.
we were doing?
Sure.
Well, if you can, I guess you were kind of going along. We're going to keep rolling that video. But again, the water we see down there is supposed to simulate oil coming up out of the ocean floor.
That's right.
I assume, right? And there you go. You have the long tube up top there. And what are you putting down there? The actual magnets. Is that correct?
Yeah, we're putting a mixture of magnetized material and steel balls. The steel balls become magnetized once they attach to the magnet balls.
Now, and essentially you're clogging this thing up, but you can't, is it possible, you said 75% of the flow, is it possible to cut it all off, or would you not want to do that?
Well, that was the whole idea, was to understand as you apply materials, can you control the stoppage, and you can. What you see there now is we've added enough pipe there so that we can add more materials, and in this case we've reduced it to 75%, but again, if we would add more pipe and more material, we would bring it down to a very controllable trickle.
Now, this is one thing, to do this at a lab somewhere on land. Now, what gives you confidence you could do this 5,000 feet below the surface of the water?
That's right, and that's the engineering aspect. We know that there's access below the BOP to introduce a non-magnetic tube, such as an aluminum tube. We can bring it down there. We can force the balls down there with high-pressure water or even mud. As soon as they come out of that pipe, they will start attaching to each other and attaching to the steel wall and form a very, very strong clot. You can slowly bring that pipe up, almost like pouring concrete. And again, keep adding as much as you want until you get the leak controlled to the level that you want. There are some concerns about actually fully plugging it because of the back pressure. But again, here we can control it and control the flow.
Now, has this been applied anywhere else? I know certainly we haven't seen anything like this Gulf oil spill, but anywhere else this has been tried out in the real world?
Yeah, actually in the 1979 iToxic spill, they did not use magnetic spheres, but they did use a combination of steel and lead balls to significantly reduce the flow. But really adding in this concept that our chief scientist developed of adding in the magnetic spheres really helps to make this a very solid solution. And again, very benign, very safe, very low risk, and very low cost compared to other activities that they've tried.
Speaking of, what would that cost be?
Well, the materials probably to do this would be certainly well under $1 million. Again, it depends on expediting materials and getting them to the Gulf, but you know, very, very low cost compared to you know, the disaster that's going on.
Sir, anybody taking you seriously right now?
We've gotten a lot of attention over the last few weeks, even talking to some people within BP who have told me privately that they think it'll work. We are pushing hard in our state as we have these tar balls start to come up on our ocean. We're hoping to get the attention of the governor We're going back up to the Coast Guard again, and I think doing this test, which we just completed a week ago, will give evidence that this concept has a lot of viability.
And you said you talked to BP, some officials within BP. They giving you any kind of confidence that they are, frankly, taking you seriously?
Well, to be clear on that, these are engineers who happen to see the concept through the media coverage, and they liked it. But, you know.
Not an official presentation?
Absolutely not. But we'd love to do that.
All right. Well, BP, you heard him. Mark Senti, he's ready to go. With he has a magnetized solution, possibly, to capping that leak. Sir, thank you for taking the time out. Thank you for the demonstration and really sharing a concept. I know a lot of people out there really would like to help. But thanks so much. Interesting stuff.
Thank you, too.